This session is about Bgp configuration, one of the Bgp attribute, that is wait. We are going to see about how to configure wait and how does it works in this session. This is our topology that we are going to see about, and there are 4 routers: R1, R2, R3 and R4. All routers are in different AS. Let's consider R1 is in AS1, R2 is in AS2, R3 and R4 is in AS3 and AS4 respectively. I have created 2 loopbacks in R4, that is 4.4.4.4/32 and 44.44.44.44/32. What we are going to do over here is we are going to configure an entire BGP in all the routers, and we are going to reach how for this particular prefix via AS3 and all other information, that is 4.4.4.4/32 should be reached via AS3, and the remaining information in order to reach R4, it should be chosen based on the default path that it uses. That is, if all the information is same, it chooses the best router ID, it chooses that path. So this is what we are going to do now. Let's start our configuration. I think I have already configured the IP address. Let's confirm it once for all the routers. Okay, I have configured all the IP address in all the routers. Nothing more than IP address has been configured. One second. I think so I have configured any protocols. I'll just confirm it once. There is no protocols I have configured. Okay, just check what is the any other configuration we are doing here in this router. Okay. There are 2 remaining things we should have to remove before configuring. Okay, only the IP address has been there. Some other configuration is also there. Everything has been removed. Okay, let's do our first initial BGP configuration. What I'm going to do it over here is I'm going to form a neighborship between each routers by using a physical interfaces. For all the routers, that's what I'm going to do now. Let's start our configuration. I'll start with R1. Okay, the same configuration is done in R2. Now I need to move on to R3. Okay, next we need to move on to R4. Okay, I have done the BGP configuration. We need to verify that all the routers have become neighbors. Let's verify it. Okay, R1 is okay, R2 also okay. Next, R3 also okay. R4 also fine. Both the neighbors have become up over here. Okay, let's verify if any routes are learning or not. Okay, none of the routes are learning. The reason is we haven't advertised any routes. We have just configured a neighborship. Now what I'm going to do is, for learning of routes between the routers, I'm going to redistribute the connected interfaces in BGP. If you want, you can also use any routing protocols as EGIP or OSPF, but I'm not going to do it as of now. I'm going to do redistribute the BGP connector routes in the configuration. Let's do it. This is how you need to do for redistribution of connected routes. So redistribute, then it's connected. While you are using EAGRP or OSPF, it might be asking subnets, redistribute connected subnets. So if you have not chosen a subnets, it will only redistribute the classful networks. If you have done anything, some sort of subnets or subnetting is being done, that is not related to classful. That is, if you are using a 172.16 class B network, it will be advertised in terms of /16. Even if you are given a mask of /24 or 28, whatever it be, it will not be advertised in a particular network. It might cause some sort of issues in real-time networks. So in order to avoid that, it's better to choose as subnets in such cases. Now I'm going to do redistribute connected. So what happens if I do this means, what all the information that has been manually advertised, that is by using an access list or prefix list, if you want to import something or export something, if you are using a network command by using advertise something, if that is not done, it will choose all other interfaces as a redistributed networks. If you didn't get my point, I'll say as go to this topology. Okay, now you are having a 2 loopback interfaces on this information. In R4, you have 2 interfaces over here. You are just forming a neighborship with these routers. What if you want to advertise something from this router to other routers? You can use the routing protocols, or you can redistribute the directly connected interfaces. If you use redistribute connected, means what happens, all the interfaces will be advertised in BGP. It will be seen in the BGP table. I will show you something here. If you put show IP BGP, none of the information will be there. The reason is we haven't given any prefixes in BGP. So what will happen if I give a redistributed network is all the IPs, all the interfaces that you have configured in the router that has been directly connected will be given into the BGP routing table. But will be given, all the interfaces will be given, but it will be given in terms of two things. One is a redistributed network. By default, if I give, all the information will be redistributed over here. But if you are advertising it manually by using a network command, that will be in different way of approach, and redistributed information will be in different way of approach to the other networks. That is, if I say this 44.44.44.44/32 in a network command, it will be given a higher priority as compared to the top 4.4.4.4, which is being redistributed. So this is what is about. All the information will be redistributed, but if you want to manually given some information, that will be given a higher preference. So that's what is about redistribution. That's the basic information about redistribution. We will see in the upcoming sessions what is about redistribution and how to configure it in a wily manner. Okay. If I give redistribute connected, all the interfaces that are up in state, that is in active state, will be redistributed. Okay. So we are going to give this command in all the routers so that every prefixes will be advertised. Okay. Now let's see the same command show IP BGP, which I have given a few seconds back. There's no information in the table. But if I give show IP BGP, you can see the entire information over here. So what these informations are all about? This is about weight, and it's a local preference metric, and next hop, and this all the networks that is being given via BGP. So let's have a basic look about what these are. So these are some of the attributes that BGP takes in order to choose the preferred path. That is from this next hop to this end. Okay, what this information is all about. These are the networks that is being advertised by BGP, but these are all the attributes that it chooses in order to reach a destination. Okay, next, what this star and arrow mark. So what this means is, if you look at here, the star is a valid route, but this arrow mark, that is the right side row, is said to be as the best path in order to reach a particular destination. If you look at this network 192.168.12.0, there are two valid routes in order to reach the destination. But the best path, what the router chooses is this information, that is 24.2. It chooses the next hop as this in order to reach this network. How does it choose this network is, it chooses based on here. First it chooses weight, local preference. Here you can see the AS path. It reaches two AS path in order to reach this destination, this network. But this network, that is 24.2, wants to reach via single AS. So in this case it chooses this. But in some cases you might have seen everything seems to be okay, but it chooses a particular network. At that situation it chooses a best network address in order to reach a destination. Okay, this is about basics of BGP table. Okay, let's move on to R1 and do our concept. Show IP BGP. Okay. Okay. Now what we are going to do is, you can see in order to reach this network, it chooses 13.3 network, and 44.44.44 also it chooses a 13.3 network. In order to reach these two networks, there is two loopbacks that has been configured in R4. In order to reach that network, it chooses 192.168.13.3. If you look at a topology, 13.3 belongs to AS number 3. So this is what the route it chooses in order to reach a destination. Okay. Now what we are going to do is, since all the routes you can see 24.0 it chooses 12.2 and 34.0 it chooses 13.3. This is all the path that it chooses by default in order to reach a destination. Okay. Now what we are going to do is, I'm going to configure a route map, that is a BGP weight weight attribute. I want to reach this 4.4.4.4/32 via this path. Since now it route chooses this path, I'm going to choose this path, that is via R2. The remaining information, that is the loopback 44.44.44.44/32 will choose this path. We are going to focus only on two interfaces, that is in order to reach this 4 network and 44 network. In order to reach a 4 network, it has to choose AS2, while it has to choose a 44 network, it needs to go via R3. So this is what the information that we are going to configure. Okay. It can be done by two ways. We can set directly the weight, but for all the information, once I'll show you the configuration part. Okay, you can see here, if you want to set a weight for this neighbor, you can set it here directly. So what happens over here is that it will choose only this neighbor in order to reach our destination. The high priority will be given to this neighbor. Whatever be the route it needs to reach, it goes via this router. It's not based on the prefix. Whatever the information the router leaves, it chooses this interface and passes. It chooses this as an extra and the information gets passed off. So this is one way of configuring a weight. But if you want any particular network or particular prefix, this can't be done. You can done it with the help of a route map. So let's do it with the help of a route map now. Okay. First, we need to create a route map. The steps here are, first need to create a route map, and then we need to set a weight. That's it. But if you have any network, we just want to match that network. Oh, this is a basic way of configuring a route map. Let's do it. I'm choosing a route map with the name as weight. It can be any name as you like. And then you can leave it directly. Or if you want, you can give a permit or any. If you are having a same route map name with 2 or 3 scenarios, that is a weight permit 10, then permit 20, permit 30. If you want to add a rules, then you can choose a permit. By default, it chooses a permit value of 10. I'm going to route map, wait, that's it. Now I'm going to set a wait. Set wait. By default, the wait is 0, but for directly connected interfaces alone, it will be 32768. Now I'm going to set a wait of 700. That's it. This is a basic configuration, but we want to match our prefix, that is 4.4.4./32. This segment has to be matched in order to reach up AS3, in order to reach that network. So what I'm going to do is I'm going to match IP address. Then you can give a access list number or a prefix list if you want. We haven't dealt with prefix list yet, so I choose a access list itself. So it can be a standard access list or extended access list or even named access list, whichever you want, you can do it. I'm going to go on with a standard access list, match IP address number 1. That's it. So if you look at a route map, show route map, it's showing as a route map name is wait, and it's a permit, and the sequence number is 10. That is a permit sequence 10. And we are matching match clauses. We are matching the access list number 1. And what we have set is wait value 700. And this is what we have done. Now what we have to do is we need to create an access list with number 1. And we need to match our address for the wait 700. Let's do it. That's it. Configuration done in terms of route map. But we need to apply this in Bgp configuration in order to take effect. As of now, for this network, the route chooses 13.3. Now I'm going to apply it on 12.2 with route map. What is the route map name is wait, and I'm calling it as inbound. That's it. Okay. Now the route goes via 13.3. In order to take this effect, we just want to clear the BGP and we reset the BGP. We can confirm this whether the traffic goes via route map is working or not. Before that, I just want to show you one thing in R4 between the relationship connected and a manual advertising network. Now I'm going to do a manual advertisement of this network 44.44.44.44. Okay, you can check it here as 44. Just see it clearly. It's showing as AS024 and it's question mark over here for this network. So we have done. This is how you need to manually advertise the network in BGP. Okay. Now if we check the same configuration, this is how it looks like. You can see as in order to reach this network, it's showing as I. It's not a question mark, but if you look at here, it's a question mark, but here it's I. I means internal. That is, it is being advertised manually by someone. It's not redistributed. Redistributed means it's question mark, it will be shown as. That is something related to that of incomplete. So that's the difference. As compared to question mark, I is more preferred. So this is how the redistributed networks and manually advertised network we can differentiate here in the BGP table. Okay, let's come to our part. Okay, what I'm going to do is I'm going to clear the BGP table. I'm going to do a soft reset. Okay, you can see it here that 4.4.4.4 is moving via 13.3 with a weight of 0. As soon as I clear the BGP, now you can see the path. See here, the path is 13.3. Now the path moves to 12.2 with the local preference value of 700. But for this network, it's still 13.3. So why it chooses this network is we have manually advertised. So let's remove our manual advertisement and check it. Okay, now it's been removed. So it's again question mark. So it's a redistributed network. So this is how a route map works. That is, by using a route map, we are calling it is in inbound, and with the help of local preference weight value, it's not local preference, weight, higher the weight is being preferred. As we compare this weight to which neighbor has a higher local preference, it advertises the network to the concerned peer. So this is how local preference of weight works. So to be more clear in steps, first we need to configure our route map. So what we have configured is weight, route map number name is weight, and a match access list and a local preference. Sorry, it's a weight value. And then we have matched our access list 44.44.44.44. This is how. And then we need to map it to the neighbor, to which neighbor we need to point it. So we have pointed to the neighbor 12.2 route map weight in. So this weight, it will check into the route map. So route map has an access list of 1. It will check this access list number 1. So access list number 1 has a match prefix of 4.4.4.4. So if it matches this, it needs to have a weight value of 700. So this is how it works. Then automatically the 4.4.4 will set a value of 700. So the path will be moved on to 12.2 instead of 13.3. So this is how you need to configure a weight in BGP. This is the first attribute, and if weight is compared, it will not check into the other attributes, and this is Cisco proprietary also. That's it. Thanks for watching. Until next time.